So like I was saying, right, in place of x of n, you can substitute, since x of n is basically equivalent to half to the power of n, u of n, right? And we have a u of n here as well. So u of n multiplied by u of n is just going to give me u of n. So I can just write u of n and half of, half to the power of n, right? So this is what we get as a product of, I mean, the resultant of this particular function over here, right? Then the next thing is that how do you go about plotting this? You have two ways, right? You can, I believe all of you know what this indicates, right? So I'm not going to go upon like both the methods. So I'm just going to briefly show, tell you, right? So the brief method is that the first thing is to plot both the functions and then multiply it with each other, right? Because this is just a multiplication, isn't it? So if we were to just multiply it, so half to the power of n is just going to basically give me a graph of something like this, right? It's going to be a discrete graph, right? But though I'm drawing it in a continuous form just to sketch it out, right? And then we just need to multiply it with u of n. So it is going to give a amplitude of 1. So if we had to multiply all this particular part, this particular portion, or the negative side of the x-axis is just going to give me 0, right? So basically we have these particular values, right? Whatever value you have multiplied by 1 is just going to give me a graph of this, right? Okay, this particular graph. So basically for half to the power of n, we just need to plot for all n is greater than equal to 0, right? That's one way. The other way is you can directly interpret it from this particular equation over here. So since we have a value for half to the power of n, which is n, we have a value for half to the power of n, right? And if we multiply that by 1, it is going to give me the same value again as it is. And u of n starts from n is greater than equal to 0, right? So u of n has a value of 1 for n is greater than equal to 0. So basically, like I showed, we'll be having a value, right, for all n values for n is greater than equal to 0, right? And we just need to plot this particular function. When we plot this, we get something like this, right? So the first value, when n is equal to 0, it is basically half to the power of n. So half to the power of 0 is basically going to give me anything to the power of 0 is just 1, okay? Next is when n is equal to 1. So the value at n is equal to 1 will be half to the power of 1. So if you evaluate half to the power of 1, you're going to get half. And then n is equal to 2, just substitute 2 in place of n, you're going to get 1 quarter and 1/16th, and then so forth, right? So you are going to get a graph of something like this for this particular function, right? I believe all of you have already learned this in DSP, E392, but I was just going over it again, right? Question number 5, right? Given x of t and y of t as follows, evaluate x of t multiplied by y of t minus 1. Okay, so you can see that the functions of x of t and y of t minus 1 are given over here. Okay, so what does this indicate? We just need to multiply the functions to get the product of it, right? In order to evaluate x of t multiplied by y of t minus 1, isn't it? So what we do is we align the graph, right? We align this graph. So we draw that, right? X of t, this is the function we get. Y of t minus 1, this is the function we get, right? So from -1 to 0, you can see we can divide this into several sections, right? From -1 to 0, and then we have a value, we have a different graph from 0 till 1. Then we have a different graph from 1 to till 2, and then we have a different graph from 2 to 3. The same goes for this, right? We can divide it into multiple segments, right? So we can divide the graph of y of t minus 1, right, into multiple sections, right? Now, we can evaluate it directly, right? So between -1 and 0, right? -1 and 0, we have a value for this, right? For x of t, right? This is what we get. And for y of t minus 1, we get a value of 1, right? This is, the value is missing, but the amplitude over here is 1, right? So 1 multiplied by this, 1 multiplied by any value is going to give me that particular value, isn't it? Like a times 1 is going to give me 8, isn't it? So basically, if I'm multiplying this graph with this 1, what I'm going to get is the same graph back, isn't it? So let's say we have a value of a between this -1 and 0 region, right? And we have amplitude of 1 over here. So a times 1 is going to give me a. So this is what we get, right? This portion multiplied by 1 is going to give me this for the region between -1 to 0. Next region is from 0 till 1. So from 0 till 1, we have something like this, right? For x of t. And we have a negative value for this, right? -1. So whatever value you have over here between 0 and 1, it is now reversed, right? We have a negative value. So basically what that means, the graph between 0 and 1 is being reflected across the x-axis, right? Right? So this is what we get, right? And then we keep on doing it for the next two regions as well. Between 1 and 2, we have a value of 1. 1 and 2, we have a value of this, right? And this is just 1. So 1 multiplied by some value b, we are going to get this same graph. So again, from 1 to 2, we are going to get this graph, right? And it stops at 2, right? And then we have another region from 2 to 3. 2 to 3, it is again 1 multiplied by some value c over here. So we have this particular graph, right? 2 to 3, we have this same particular graph over here, right? Any questions how we get this? So basically we are dividing this into multiple segments and multiplying the values over here with the values over here, right? So this is what we are getting, okay? So if you multiply both the graphs, this is the product that we will be getting, right? Question number 6, sketch the following, right? X of t is equal to u of t plus 1 minus 2u of t plus u of t minus 1. And we need to plot y of t is equal to a ramp function, right? R indicates the ramp function, so r of t plus 2 minus r of t plus 1 minus r of t minus 1 plus r of t minus 2, right? So let's plot this particular function, right? So u of t plus 1, the graph of u of t plus 1, let me draw a axis. The graph of u of t plus 1, what does this indicate? The graph shifts 1 unit towards your left, right? So we have a graph something like this, right? Right. So this is one, next one, right? And then the next graph is next is minus 2 u of t. So u of t has an amplitude of 1 for t is greater than equal to 0. And then we are multiplying by -2. So the graph of minus 2 u of t is going to look like something like this, right? The amplitude is going to be -2. The amplitude over here is 1, okay? And then the next graph is it's a positive u of t minus 1. So what this means is that the graph of u of t has shifted 1 unit towards the right, okay? So we are going to have something like this, okay? Value is 1. Now, we have something like this, right? We have plotted all this graph, okay? So now what we can do is we can add this graph, right? Because the operation between all these is plus, right? It's addition. So all this region before -1 has a value of 0. So before -1 is all 0, okay? And then from -1 till 0, right? -1 till 0, we have 1 plus 0. So we have an amplitude of 1. So that's how we get the amplitude of 1 over here. And then from 0 till 1, right? From 0 till 1, what do we have? We have 1 plus 0 plus -2, isn't it? So what is the resultant of this? 1 plus -2?
-1.
-1. So we get -1. So if you continue doing this, right, we are going to get something like this, okay? let's move on to the next part of this, plotting y of t, right? Plotting y of t. The ramp function looks something like this, right? Just in case if you're not, if you have forgotten about ramp function, so the ramp function basically looks like this. This is a ramp function, okay? It has all, I mean, anything before t is equal to 0 is all 0, and then from t is equal to 0, it starts to increase, right? It ramps up, okay? This is the ramp function. So if we were to draw that, right? So what we can do is we can divide into multiple segments, right? This same equation, we can break it down like we did for the first one, and then we can plot it, right? So let's quickly drawing that. Ramp function of t plus 2 is basically shifting the ramp function 2 units towards the left
side.
So we're going to have something like let's plot axis, and then what this means is we are going to have something like this, right? And the point where it starts to rise is minus 2. From minus, I mean, the next thing is negative ramp function of t plus 1, right? So what this means is the ramp function has been shifted 1 unit towards your right, right? 1 unit, oh sorry, 1 unit towards your left, and it has been inversed. So basically what we have is something like this, right? We have same thing, and it's negative 1, it is going to go down, right? Rather than increasing, it is now going to go down, okay? This is 1. And the value over here in the intersection value will be minus 1. Intersection value over here is 2, okay? Next is this particular function. Again, this indicates that the ramp function has shifted 1 unit to the left, and it has been inversed, right? I mean, it has been reflected across the x-axis, right? Because of this negative. This negative indicates that a reflection across the x-axis, okay? So 1 unit towards the left, and it is going down, right? I should have changed the color of this. We have something like this. And then drawing the temp function from here to here, I mean, for this particular function, r of t minus 2, this indicates that the ramp function has shifted 2 units towards the left, right? So we have something like this. Okay. 2, this is 1, minus 1, right? And then minus 2. So we can break this all of this graph into, I mean, it has no value uh, before negative 2, isn't it? The addition of all this graph has value of 0 for all t is smaller than negative 2, isn't it? So automatically this part is all 0, right? And then between negative 2 and negative 1, we have the ramp function over here, right? So whatever value we have, it goes up to negative 1, right? So we have this particular value over here. So that's the slope that we get, right? Because all the other values are 0 at this particular region, right? Between negative 2 and negative 1. And then from the region between negative 1 and 0, you can see we have only 2 graphs, right? This pink graph is basically equal to 0. So we have this red one, and we have this blue one from here to here. So if we add that, right, you can say the difference between these two values, right? When you are adding this, basically what happens is whatever positive value you are adding to the negative value, and the gradient is same, isn't it? So the gradient is 1 over here, the gradient is 1 over here. But this blue line has started 1 unit before it. So basically it has a extra unit, right? I mean, like if you look at the value over here, right, at negative 0.5, this particular graph will have a value of uh, of mm, of 1.5. Okay, at this particular point at 0.5, at this particular point, this blue line has a value of 1.5. The value of this red line, it is going to be 0.5, right? Minus 0.5. So if you add it, you are going to get 1, right? 1 is your, uh, 1 is your, uh, 1 is the sum of all the graphs, right? At this particular point, at minus 0.5. Then if you shift to t is equal to 0, right? Again, you can see that this particular graph is 0 again. So we only have the values for this graph and this graph. So we have a value of -1 and we have a value of 2. So 2 plus -1 is again going to give me 1. So that's how you get a value of 1 between the region of -1 and 0, right? Basically adding these graphs, right? So if you keep on adding it, you're going to get something like that. Okay. You can try it out, right? It is best if you try it out, right? So let's move on to the next question, question number 7. Right, question number 7 is to consider the given system shown below. Determine the output y of n in terms of h I of n and x of n, where I is equal to 1, 2, and so forth, right? That's till 5. So this is the system given over here. We just need to we need to determine y of n, right, in terms of h of n. So basically what this means is we need to evaluate the transfer function over here, right? And then multiply it with x of n in order to get y of n. Remember, you have done this in your in EE 312 and EE 323, right? In control system. So the transfer function, just by looking at this, you can see that these two blocks are in series. So h1 multiplied by h2, and it is being summed over here. h1 times h2, right? h1 times h2 plus, right? Plus, right? Plus, right? Plus, um, this one is alone, so just h3, and h3 block is being subtracted, right? So minus h3, so minus h3 of n, and these two blocks are in series, so h4 times h5, and it is being added, right? It's a positive, so it is being summed again at this particular junction. So we have h1 of n times, I mean, convoluted with h2 of n, right? This is what this particular block is being subtracted, so minus h3 of n, and these two blocks are in series, so h4 of n convoluted with h5, right? And this forms the transfer function of this particular system over here in between. So now if you convolute this whole system with x of n, you get y of n, isn't it? So this is what we get. So y of n is basically represented as y of n is equal to h1 of n convoluted with h2 of n minus h3 of n plus h4 of n convoluted with h5 of, right? The whole thing convoluted with x of n. So that's how we get this, right? You getting it? All of you guys are getting this?
Yes, sir.
Yes, sir.
Okay. Just in case if you don't get it, please do ask me again. And the last question is given x of n as follows, determine the output x of 2n, right? So what this indicates is that the graph is going to
Suppress, compress,
compress or
compress.
compress. Okay,
Yeah.
Compress.
okay, it is going to compress, right? And value is no, this graph is going to actually going to increase, right? It is not going to. It is going to increase or compress or decrease, I mean shrink or
Expand or compress, eh?
yeah, expand or compress. What do you think?
Compress.
You think compress? Okay, it is going to expand. Really, I think. Let's just quickly check. Compress and expand. Stretch graph. Right? right? So this indicates if we have a larger value, right, inside, or we multiply it with x, it is basically going to compress, right? And if it has a smaller value, it is going to expand. So basically, in this particular case, it is going to compress, right? It is going to compress. So what happens is that if it's going to compress, it is going this one values will shift inwards, isn't it? Inwards. So anyway, let's directly evaluate it. If you are to evaluate this at x of 2 of n, right, when n value is equal to 0. So when n is equal to 0, what do we have? 2 times 0 is going to give x of 0, isn't it? So from this particular graph, it is
Yes.
going to give 0. Then when n is equal to 1 in x of 2 of n, so we just substitute 1, right? So we get x of 2, isn't it? So x of 2, go back to this x of n graph, x of 2 is basically having a value of 0, right? There's no value over here. So that's how we get 0. And for n is equal to minus 1, so in just substituting minus 1 in this particular function, x of 2 times minus 1, so that is going to give me x of minus 2. So what do we have the value over here? X of minus 2, do you have any value?
0 as well.
That's how we get it, right? So this tutorial was pretty much simple, right? I mean, I was just exaggerating most of the parts, but otherwise, if you just look at this tutorial was pretty much simple, right? You just needed to define the signal. You needed to define the period, whether the signal was periodic or not periodic. So over here, it was non-periodic because it did not continue, right? At a certain point, if k value, k value is actually bounded, so it is not periodic after k, for values of k is greater than 5 and for k is less than minus 5, right? It is not going to give me any value, right? So that is why this particular function is actually bounded, so it becomes non-periodic, right? After a certain point in time, it becomes non-periodic. Over here,
So this kind of problem you have to look at whether it's bounded or not by the value of k.
yeah, let's just a simple rule of thumb is that you can just see if you have a function, let's say any function. So if we fit this particular function over here, if we take this function, omega of t minus 2k, right? If we take this particular function, this particular 2 minus k is actually the term that actually causes it to be periodic, isn't it? So if this particular 2 minus k is actually what is if k is the variable that is being bounded, so it is not going to be continuous after a certain point in time, right? If you try plotting the graph, it is not going to be periodic after a certain point in time, right?
Okay, yeah.
Okay.
Yes.
Okay. So actually, you should have you you should actually try to plot this particular graph. I'll try plotting this in the next session, right? But in the meantime, please do try it out so that you are able to figure it out, right? But simple rule of thumb: if this k value, the term that makes the function periodic, if that is being bounded, then the whole function is non-periodic. Okay, you can see the k value is not bounded over here, so it is periodic. Okay, that's just a simple rule. Try plotting this, and you'll be able to see that after a certain point in time, it is not going to be periodic, right? Yeah. That. So I'll end this session over here, right? And
Sir,
yeah.
Excuse me, sir.
Yeah.
Just a quick reminder. You told us that you are gonna distribute the textbook or something. I forgot.
Okay. I'm going to just drop it in the Viber group, right? Just give me 1 hour. So I have a meeting straight after this, and I'm going to drop the textbook in the Viber group. Okay.
Sir, thank you.
Thank you.
Thank you.